Hello everyone, this is Akash Chauhan again, and in today's lecture we will discuss about the unary operator overloading. In our previous lecture we have discussed about binary operator overloading. Why this example we have considered as a binary operator overloading, because we have used two operand as a left and right side for the operator, or the addition operator for addition operator. So the addition operator by default expect these value to be primitive type like integer, float, or something like that. But we have provided our own custom function by with the help operator keyword, and the operators the compiler can understand. We can make our own custom method, and for the same representation the compiler would forward this logic to here. Not by default it would consider t1 and t2 are the primitive data type. It would say if they are testing type, then it would forward to here, and whatever logic we write here, and it depends on the kind of data you would return, the output would be according to that. So this is the binary operator overloading. But in case of unary operator overloading, we only require one operand. Okay, for example, here it is a pre-increment operator. So this is a pre-increment. Okay, but by default if it is an integer, t1 is an integer, then the compiler would have no issue. But if it is a testing object, okay, so if I run this code, it would again say the same error we have encountered during this without providing our own custom method. So it would say t1 is the testing operand, not the primitive data type. So to resolve this issue, we can create our own function. So whenever the compiler would understand this is not a primitive data type, it is a testing object, then the compiler would ask the testing class, do you have any handler function for that, so that I can call. So to call that, what we can do, we can simply call the custom method. So let me write the custom method. So to if we have returned the addition custom method, what we have done, we used operator and plus. So in that case we will use operator plus plus. Okay, so let me write the function. So the function is operator plus plus. Okay, so as it is a unary operator, it would not expect to have any parameter over here. Okay, so let me see. So after pre-incrementing of t1, it would return t3. The data or the result would get stored in t3. t3 is a testing type. It means the return type of this would also be testing type. So what is the best way to do that? Take a temporary testing object and populate that, right? And at the end return that, return test. Okay, and the test would get stored in t3 eventually. Okay, we are not focusing on this statement, we are focusing on the pre-incrementing of the testing object. Okay, so here it is. So it would say if it is a primitive data type and t1 is, let's say, 1, so it would first increment and then return. This is the quality or the property of pre-increment of any primitive data type. So in that case, what it is saying, that the test, the data you are returning as a, okay, the first it would first increment the caller data a. Again, I can write the same for b. It would say you first increment your caller data and assign to me, and then assign data I will return. Okay, so if I simply display t3 over here, okay, let me comment it out. Okay, so if I simply display it, so t1 would get incremented. Okay, So the T1 data is 1 and 2. Okay, so here A and B would be 1 and 2, but it would get incremented. Okay, and this the same for that as well. So 1 would become 2 and 2 would become 3. So for testing A and B, the data would be 2 and 3. So let me run this code and see if we are getting 2 or 3 or not. Oh, okay. The issue is we have not written the return type. Okay, the error is coming over here. So we have to write testing uh, uh, return type over here, because this is the testing type, otherwise it would throw error. So let me run the code now. I think it would work fine now. Our output would be 2 and 3. So our data is 2 and 3. So this is actually the pre-increment of not the primitive data type. Right now it is testing data type, pre-incrementing of a testing data type. So we can say it is a unary operator overloading for pre-increment operator. Okay, so it means it is overloading the pre-increment operator. In case of object, it would forward, the compiler would come here and execute instead of the default way of knowing how to pre-increment a primitive data type. So we have overloaded this function. The same name, the same signature, but the meanings are different. If you would pass primitive data type like integer and float, it would behave differently. If you pass testing data type, it would behave differently. So guys, this is the unary operator overloading. How about if we can also write, let me comment it out. How about if we can also write about the post increment? So T1 plus plus. Okay, so if you pay little attention, it is also a unary operator again, right? It is a post incrementing operator. It is not pre, it would be a post increment operator, right? Instead of pre would be, it would be post increment operator. But how to overload, that is the question. So this is the question, how to overload it, right? So because for that we have created this function, but in that case it would assign the value first and then increment. Okay, so eventually the T3 would be same as T1 and the T1 would get updated. Okay, this would happen in the post increment operator. So for that, let me write the code. So again, this time I would not make the same mistake. It would return the testing object. So I will store the data in testing operator, and again plus plus. Okay, and in that case, again I will create a testing object, and I return the test at the end. Okay, at the end I would return test, and let me populate it. Test A would be actually the caller data, and test B would be the caller B, and then their value would be increased. First, the value will be assigned, that is the property of post increment. Okay, post means after that you incremented, post increment. Okay, and then the same data would be returned. So in that case, if I simply run it, okay, then it would T1 is 1 and 2. So again T3 data would also be 1 and 2. But if I write T1 dot display, the data would be it would the data would increase, it would become 2 and it would become 3, but for T1, not T3. T3 would be same as T1 initially. But if you pay little attention, okay, both the signature of both these methods are same. Okay, so let's say if I uncomment it, then how the compiler would understand you are calling pre-increment or the post-increment? They are both unary operator overloading, but how they would understand? So there is a so the compiler can easily understand which one is the pre-increment or which one is the post-increment operator you are calling over your any object. So in case of post-increment, you simply write int over here. Okay, so there is no such difference between the calling functions if you pay little attention to. Okay, they are the same. Okay, you are using plus plus over here, post, you are using plus plus pre as a pre operator, as a post operator over here. But in the signature, you are not, passing any integer. Okay, in in case of post, you are not passing any integer. Okay, like over here, it is just the way of a compiler to distinguish between if you have the same name pre-increment or post-increment. This is the way I will distinguish that this is you are meant to call post operator. Okay, so what I'll do, I'll comment it out, and what would be our output? T3 would be same as T1, and T1 would get incremented. This would become 2 and this would become 3. So let me run it. Okay, so it is saying 1 2. Why? This is the data of T3. It is same as T1, and then T1 data is 2 3. The data A has become 2 instead of 1, and the B became 3 instead of 2. So guys, this is about how to overload pre-increment and post-increment operator. They both are unary operator. If you want to know about the binary operator overloading, go back to my previous lecture. I have discussed about the binary operator overloading over there. Okay, so thank you guys for today's lecture. We are done with the unary operator overloading in C++.